Hey there, CJ Math students, and welcome to Notes 2.21 Part 2. So now we're going to go ahead and try and really tackle some kind of complex problems by looking to cross-cancel by changing any division we see to multiplication and using all the tools in our toolbox. So first, let's look at number 6. So we have 16 times negative 3/8 plus 16 times 1/4. First of all, you should ask yourself, let's go ahead and change these 16s to 16 over 1. Now notice we cannot change the order. We can't say I want to do 16 plus 16 first, right? Because multiplication in order of operations comes first. So I'm going to have to multiply these two numbers and then multiply these two numbers and then add them together. So there's no flip-flopping around here. So we'll say 16 over 1 times negative 3 over 8, and we're going to add that to 16 over 1 times 1/4. Now let's look to a cross cancel, right? So 16 and 8 can divide by 8. So 8 divided by 8, 1. 16 divided by 8, 2. And let's multiply straight across. So this part right here gives us 2 times negative 3, negative 6, 1 times 1 over 1, plus, and let's do the cross canceling here. 16 and 4 can both be divided by 4. So 4 divided by 4, 1. 16 divided by 4, 4. Let's multiply straight across. And we're going to get 4 times 1, 4. 1 times 1, 1. And now look, we have the same denominator, so we're good to go. Basically, all we're doing is adding a negative 6 plus 4. That's DSSM, if I remember my addition rules. That gives me negative 2 because I had more negatives. So there's my answer, negative 2. Let's look at number 7. So notice here we have a combination of multiplication and division and some more multiplication, right? So I think it might be helpful, first of all, to recognize that 4.2 seems like the outlier here, right? So if you look on your reference sheet, you might find that 0.2 is 1/5, or at the very least, you can say 0.2, hey, that's in the tenths place, and 2 over 10, if you simplify it, can also get down to 1/5. So really we have 4 and 1/5 times, I'll change that to a dot to make it a little bit easier for us to see, times negative 1/3. And now let's change this division to multiplication, because remember, we're always going to flip that second fraction anyway. So times 6 over 1, and then this is still times a negative 10. And we can put that over 1. All right, so now there's still one more thing we want to do, right? And that is to take this mixed number and change it to an improper fraction. So again, basically using all the tools in our toolbox to try and solve this problem. So negative 1 over 3 times 6 over 1 times negative 10 over 1. So now we got a super long multiplication problem, but we can do some cross canceling, and we can move stuff around if we want to make it easier. It's really up to us. Technically, right off the bat, I just see 21 and 3, so I just want to go ahead and say, let's cross cancel those. 3 divided by 3 is 1. 21 divided by 3 is 7. And now, in my head, I'm going to ask myself, all right, since I'm multiplying, how many negatives do I see? I see 2 negatives. That's an even amount of negatives, so my answer is going to be positive. So wonderful. I don't have to worry about the negatives. Now let's just multiply straight across. 7 times 1, 7. 7 times 6, 42. 42 times 10, 420. So again, how did I get that? 7 times 1 was 7. I took the answer to that. 7 times 6 is 42. I took the answer to that. 42 times 10, 420. Over, and then again, multiply straight across. 5 times 1 is 5. Times 1 again is 5 more. Times 1 again is 5 more. So basically, we have 420 over 5. This is a difficult problem. There's so much involved, but we have the tools to solve it. 5 goes into 42 8 times because that's 40. We now have 2 left over, so bring down the 0, that's 20. 5 goes into 20, 4 times 84. So that's a super complicated problem, but the wonderful thing is we have this toolbox of we know how to convert decimals, we know how to divide fractions, we know how to cross cancel, we know how to simplify. All those tools come into place when we're trying to get the answer to this very difficult problem. And look at that. We end up with a beautiful clean number of 84. Right? That is the end of part 2.